Project code ITPW15. Project title A multi-level distributed hybrid control scheme for islanded DC microgrid. For the DC microgrid application, DC microgrid, the grid it is widely used for the it is like a small grid because in a domestic area we are connected to the DC microgrid. In case in a small area we have a solar PV, small wind power, means we have to combine with our resources and connected to the DC grid. So we have the two system. One is centralized and other is distributed and non-centralized. Actually, in case we have one system, it is hub means it is hub. It is a DC grid means we have to connect it some other energy sources like solar PV, battery, or wind, or supercapacitor. Yeah, all the energy sources we connected and connected with the hub means it is centralized system. And in case not connected with the hub and connected individually, and PV to wind, wind to battery, and solar to supercapacitor to PV, battery to wind, it is non-centralized. Non-centralized system. In a distributed system, is combination of both the advantage. Like it is hub, all the systems are connected in hub and also individually. It is our proposed centralized distributed system, which is implemented in our DC microgrid. In existing concept, normal centralized and decentralized system is used. So only boost operation, boost converter is used individually, like PV to load or battery to load, or in sometimes a PV to battery. Each having some boost converter, boost converter, boost converter, boost converter. It is complicated. In existing concept is handled in case we have to satisfy the demand, but the solar PV input, actually climatic condition is worse means we are getting the desired output from the PV. Desired output not getting, depends upon the varying PV irradiation. So the load demand also varying. So we did not satisfy the load demand. So in order to satisfy, we have to combine some other energy sources. Okay. Mm, it is a major drawback of the existing system. But in a proposed system, we use the distributed system. Here we use solar PV, battery, and supercapacitor, and using the bidirectional converter. Bidirectional converter, because it having a two-way communication, battery to load and the load to battery. The both is possible in a bidirectional converter. In a proposed concept, load demand is changing means easily satisfy the load demand. In case the input solar radiation change also, we get the desired output. And it is a three input one output system, like three input PV, battery, solar capacitor, and one output its load. Sometimes three output one input system also, like a three output means battery, supercapacitor, load is act as output, and the panel give the ignite give the supply to the these three sources. It is highly reliable and easily regulate the bus voltages. It is a proposed black diagram. Here solar PV to battery and load, because solar PV, it is not a energy storage device, so only the one side communication, one side travel is enough. So the boost converter is used to give to the load, and the battery is connected to the bidirectional converter and supercapacitor also. In case we did not get the required input from the solar panel, means the battery already stored energy from the battery and supercapacitor to given to the load. In case both in case solar irradiation is so high, means given to the load and also the charging the battery and the supercapacitor. The supercapacitor here we used because of it has a able to charge and discharge fast. So the supercapacitor instant charging discharging take place, so it is very helpful for the instant charging and discharging. The application is mainly used for grid connected application and renewable energy application and DC microgrid application. This concept is implemented using the MATLAB 15B version. And in a hardware prototype, the microprocessor lab software is used to give the program for the PIC microcontroller in our prototype. The hardware, mainly the major element for build the hardware prototype is the MOSFET and transformer and PIC microcontroller, solar panel and batteries and other active and passive elements. Thank you.